Hi students, in this video we are going to discuss about important multiple choice questions of first chapter in physical science, reflection of light at curved surfaces. I hope you understood the previous videos related to the important questions from Abhyasa Deepika of atomic structure, and even done the video related to the important questions of 7th chapter, that is the classification of elements, the periodic table. Now in this video we'll be discussing about important bit part which I have given in Abhyasa Deepika of Telangana. Okay, we are going to discuss about all the important multiple choice questions and how to solve those bit part. Okay, the first question, reflection of light cover surfaces. This is the first chapter in 10th class textbook. That is the first multiple choice question given in Abhyasa Deepika, and the question will be displayed on the screen. Just you see the question and look at the solution, okay, on the board. The first question is, focal length of the concave mirror is 30 centimeter, object distance is 60 centimeter, then the image distance is. The focal length of the concave mirror given, is 30 centimeter, and object distance given is 60 centimeter. First, before what he has to find out, then the image distance is, that is image distance V is equal to how much is asking in the multiple choice. It's a problematic question, but if you know the solution, firstly we can answer the bit part very easily. Then you should know how to solve this. No, before solving the problem, you should know first initially which formula you have to use. You have to use the formula which is called as a mirror formula. 1 by f is equal to 1 by u plus 1 by v, or 1 by f is equal to 1 by v plus 1 by u. So he has given the focal length. In case of concave mirror, this is a concave mirror, here it is a pole, here it is a focus, and it is center of curvature. The focal length, if you apply the sign conventions, the focal length for this concave mirror is taken as a negative. That is, focal length is f is equal to, it should take minus value according to sign conventions. And object distance is also, we are measuring the focal length from pole to the focus, opposite direction of the incident ray. That is, hence focal length is a negative, that is minus 30. And object distance given is how much? 60 centimeter. Now the focal length is from here to here, it is 30 centimeter minus value. And the object distance, if I double the focal length, what you will get? That is radius of a curvature. That is center of curvature value. Then what radius of curvature value you will get? Now if I write based on the focal length, if I write the radius of curvature, R is equal to 2f formula. R is equal to 2 into 30. Nothing but 60 centimeter is the radius of curvature. Nothing but the object is placed at C. Here the object is placed. Okay, at C the object is placed because radius of curvature R is equal to 60 centimeter. Nothing but from here to here, radius of curvature at C, we placed the object. So radius of curvature value is 60, object distance is also 60, and object distance you have to use sign convention for this is minus, because we are measuring the object distance. Light ray is coming from the candle like this, and we are measuring the distance opposite to the direction of the incident light. We are measuring the object distance incident opposite. This is incident ray direction, and we are measuring the distance of the object opposite to incident ray. Then object distance u is equal to, will become minus value, minus 60 centimeter. Then if you use the formula, that is mirror formula. Now mirror formula is 1 by f is equal to 1 by u plus 1 by v. Now you have to substitute that. In this, 1 by f is 1 by minus 30 is equal to 1 by u is minus 60 plus 1 by v. Now 1 by minus 60 minus 30. Okay, 1 by minus 60 means it will become plus this side if you bring. 1 by 60 is equal to 1 by v. Now do the LCM for this. LCM will be how much? This is for 60. 30 will go in 62 times, that is minus 2, plus 60 will go in 61 times 1 is equal to 1 by v. Is it clear? Now minus 2 plus 1, how much? Minus 1. Nothing but here I will write minus 1 by 60 is equal to 1 by v. Then v is equal to minus 60. So in the bit part, the options given is first option is plus 60, second option given is minus 30, C, third option given is minus 40, and fourth option given is minus 60. So the question is displayed on the screen. Then the option for this particular bit part is D. D is equal to minus 60 centimeters was given. This is the right answer. Minus 60 is the right answer. Okay. Now, next question. The next question is, the focal length of the concave mirror of the radius of curvature is 10 centimeter. The focal length of the concave mirror, if the radius of curvature, second bit multiple choice, the question is displayed on the screen. The focal length of the concave mirror, if the radius of curvature is 10 centimeter. Radius of curvature given is 10 centimeter. And he asked to find out the focal length of what mirror? Concave mirror. We have the relation between R and F. Radius of curvature, R is equal to 2F is the formula. Okay, he asked to find out F. F is equal to, you bring this to this side, R by 2. What is the radius of curvature given? That is 10. And the focal length is, you have to find out. F is equal to R by 2, nothing but 10 by 2. Nothing but how much? 5 centimeter. Is it clear? 5 centimeter is the right answer. So, in the questions, under the question, the options were given, which is going to display on the screen. The right option is D. Here, for this one also, the second bit part which was given in Abhyas Deepika, important bit, the option is D is the right option. And just you go through once and then you will understand. The formula of the magnification of the image formed by the object using a concave mirror is M is equal to the formula of the magnification, third bit part. The question I am reading, just the question is displayed on the screen, just check once. The formula of the magnification of the image formed by the object using concave mirror is, magnification formula is given as minus V by U. We have for magnification two formulae are there. One is based on distances, object distance, image distance. One is based upon height of the object and height of the image. Magnification M is equal to height of the image by height of the object. One formula is there. And one more formula is M is equal to minus V by U. Image distance by object distance. Two formulae are there. So, in the question was given is this particular formula. Okay. So, M is equal to minus V by U. Then U indicates. So, in this case, M is nothing but magnification. V is nothing but image distance. And here U is nothing but what distance? Object distance. And if this formula is given, okay, if you are getting this formula in the coming board examination, maybe in the coming SA1 examination, if you get it, then what does HI denotes? Height of the image. Here HI means height of the image. HO means height of the object. Okay. So, two formulae are there. One is based on distance of the object and image, and one is based on height of the image and height of the object. So, and if you want me to explain more about magnification, magnification has no units. Magnification, it has no units for magnification. Okay, has no units for magnification. Very, very important. This bit may come, or like this the bit may come, or like this the bit may come. Or sometimes you may give the values of object distance, image distance, or height of the object, height of the image, and he may ask you to find out the magnification of the image, so formed whether by using a concave mirror or a convex mirror. Okay. Which one is not possible for the magnification by a concave mirror? The fourth question is, which one among the, see the question, which one is not possible for the magnification by a concave mirror? The first option for the question, fourth question is M is equal to less than 1, M is less than 1, and B option given is M is greater than minus 1, and C option given is M is equal to greater than minus 1, and D option is M is equal to minus 1. Okay, for the magnification produced, okay, by a concave mirror, M is less than 1 is 100% possible. M is greater than, second option is M is less than minus 1. Sorry, m is less than minus 1 is also possible. M is equal to minus 1 is also possible. And m is greater than minus 1 is not possible for a concave mirror. Because here magnification is value is more than minus 1. It is not possible for a concave mirror. Is it clear? M is less than 1 is possible. M is less than minus 1 is possible. M is greater than minus 1 is never possible. And according to the fourth question, the right option is C. Remember that. And M is equal to minus 1 is possible. This is in which case means object is at C. Image is also formed at C. This is a very, very important bit. Even it may ask, you may ask in the board examination like this also. Based on this particular value, the bit may be asked in the board examination. When does the magnification value is minus 1? Okay, in case of concave mirror means if an object is placed at C, image is also formed at C. Okay, so for this particular question, which I read, and this question will be there on the screen, and right option is C, M is greater than minus 1. Now the fifth bit part is, see the question, virtual image formed due to. Okay, virtual image is formed due to. First option is, for the fifth question, I am not writing the question on the board just because the question will be displayed. Okay, virtual image is formed due to intersection of incident rays, intersection of incident rays, and next one is intersection of reflected rays. C is intersection of extending back of reflected rays. Intersection of extending back of reflected rays. And next is intersection of incident and reflected rays. Intersection of incident and reflected rays. So these were the options. Question is virtual image formed due to. You know what is the meaning of virtual image? Is formed due to. This is the question, and the question is also displayed on the screen. Virtual image is formed due to intersection of incident rays, intersection of reflected rays, intersection of extending back of reflected rays, intersection of incident and reflected rays. Okay, intersection of incident rays never forms virtual image. Intersection of incident rays never intersect. Incident rays never intersect. Means for example, if I explain concave mirror. Okay, this is a pole, this is a focus, this is center of curvature. The incident rays never intersect each other. This is one incident ray, this is one incident ray, they never intersect each other. So the first option is, okay, is wrong. Intersection of incident rays is a wrong option. And next one is intersection of reflected rays. Intersection of reflected rays will always form real images. It always forms what type of images means real. Here there is no chance of formation of any kind of image because intersection of incident rays never intersect each other. Then how the image will be formed? There is no chance of formation of any image in the first option. And second option, intersection of reflected rays will form always real images. It never form virtual image. Next one is D option will see intersection of incident and reflected rays. It is highly impossible. Intersection of incident and reflected rays. This is a concave mirror if you take. This is the pole of the mirror. This is a focus and this is center of curvature. Intersection of incident rays and reflected rays. How it happens? It never happens like that. Next one is reflected rays intersection may happen, but incident rays intersection never happens. So D option is also wrong. And ultimately the C option is intersection of extending back of reflected light rays. Intersection of extending back of reflected light rays. That is C option is right, but I will explain this one by drawing one simple diagram by using both concave and convex mirrors. Then you will understand more clearly. The right option for the given bit is C. Sir, how it is, sir? Can you explain us? Yes, definitely. Now, intersection of extending back of reflected light rays. Now, if I take concave mirror, this is a pole and this is a focus. Here is center of curvature. So if I place the object between P and F, here the object is there. This is incident ray, this is reflected ray. And this is incident ray, this is reflected ray. Okay, intersection of extending back of reflected light rays. So if you place the object between P and F in case of concave mirror, image is formed in the mirror. That is behind the mirror. And image is what? Virtual, erect and magnified image. So how the image is formed? This is reflected light ray, reflected back, and I am going to extend back this reflected light rays. Okay, so these reflected light rays are intersecting at this particular point. If I extend backwards, appears to be coming from one particular point means they are intersecting here. So this concave mirror, in case of concave mirror, virtual image is formed when the object is placed between P and F. And the two reflected light rays, if I extend back forth, they are going to intersect at one particular point in the mirror. That particular point, the image will be formed. This is in case of a concave. And if I go with the convex mirror always forms a virtual image only. And here is, this is, object is placed on the principal axis here. And in case of convex mirror, this is a pole, this is a focus, and this is center of curvature. Focus and center of curvature will be in the mirror. Okay, so this is incident ray diverging. It is diverging, for example. Now I will draw very clearly, then you will understand. If I will minimize the height of the object, then if I draw like this is incident ray and this is reflected ray, and again here, and this is incident ray and it is reflected ray. See, this is incident ray, reflected ray, divergent ray, incident ray, reflected ray, divergent ray here. So here also I am going to extend backward, back of reflected light rays. I extend back the reflected light rays, and here the image is formed, the virtual image. So the right option, in both the cases, if you observe the diagram, in both these cases, intersection of extending back of reflected light rays. So hence, in the given question, fifth question, multiple choice, the right option is a C. I hope you understood this explanation. Okay, next one is formula is used to find the focal length of the mirror. Next, the sixth bit part was given is, sixth bit part in case of first chapter, multiple choice bit was given is, formula is used to find the focal length of the mirror. The question is displayed on the screen, just you go through the question once, and the options I am going to write here to explain. Okay, F is equal to given is VU by U minus V. Okay, and the second option B was given as F is equal to V plus U by, okay, UV. And C option given is F is equal to V minus U by, okay, UV. And D option given is F is equal to VU by U plus V. So these are the options given. The question is, I think you are seeing on the screen, the question I will read out, formula used to find the focal length of the mirror. The formula used to find out the focal length of the mirror. Formula. Sir, we never saw this kind of formula in the textbook now. Then what is this, sir? Actually, the mirror formula is 1 by F is equal to 1 by U plus 1 by V. This is the formula, na sir. Or 1 by F is equal to 1 by V plus 1 by U, na sir. Okay. 1 by F is equal to 1 by U plus 1 by V, or in some books it is 1 by V plus 1 by U will be given. A plus B nothing but B plus A only. Like that, in the same way, I wrote this formula in two ways. Because in CBSE books, you may find this one. In SSC books, they are giving 1 by U plus 1 by V. Okay. Now, what is the right answer, sir, in this? Sir, how you got this? How he has given these multiple choice? Which one is right, sir? D is right answer. F is equal to VU by U plus V. How you got this, sir? Then you go with the LCM. 1 by F is equal to. If you take the LCM for these two, you will get UV LCM. 1 by U plus 1 by V LCM is UV only. U will go in UV how many times? V times plus V will go in UV how many times? U times. That is 1 by F is equal to V plus U by UV. Now F is equal to, you do reciprocal, UV by V plus U or U plus V, anything. Okay, VU by U plus V you can write, or UV by V plus U you can write. So hence the right option is D. So he has asked in indirect way and very simple to understand, but you should have basic idea of this formula and you should do the LCM process. You should know, then only you can answer this bit part. The seventh bit part given in Abhyasa Deepika important question part is, the rays are incident on the concave mirror parallel and converging at 20 centimeter. The rays are incident on the concave mirror parallel and converging at 20 centimeter on the principal axis. Then the radius of the curvature of the mirror is, listen carefully, the rays are incident on the concave mirror. I will write the options, then I will explain the solution. First option given is 20 centimeter, A is equal to 20 centimeters was given, B is how many centimeters? 40 centimeter was given, and C is 10 centimeter, and D option is 5, given is 5 centimeter. The question is, the rays are incident on the concave mirror parallel and converging at 20 centimeter. Rays are converging at how much value? 20 centimeter value. See the question on the screen. I will read out again. The rays are incident on the concave mirror parallel and converging at 20 centimeter on the principal axis. Then the radius of the curvature of the mirror is, they are converging at a value of 20 centimeter. Okay, and on the principal axis, then the value of radius of curvature is, you know that. Okay, but to solve this big part, you should know the idea about ray diagrams and the rules pertaining to ray diagrams also. And you know, he has given in the question concave mirror, he mentioned clearly, that is this is a pole and here it is a focus, here it is a center of curvature. According to the rules, while drawing ray diagrams, what are the rules you have to follow? If the rays are parallel to principal axis, if the rays are the rays are coming from the object which is at infinite distance, if all the rays are parallel to principal axis, if all the incident rays are parallel to principal axis, for example, this is incident ray 1 and this is incident ray 2. If the rays are parallel to principal axis, after reflection they will converge at a point. The point at which all the reflected light rays, this is R1 you consider, this is R2. The point at which all the reflected light rays will converge is called as what? A focus. Then I think you understood now. The question is, I will read out the question. Please concentrate on this and even listen to the question. The rays are incident on the concave mirror parallel and converging at 20 centimeter. These are parallel. We are going to incident parallel rays. After reflection, they are converging at 20 centimeter distance. Normally, all the rays which are incident which are parallel to principal axis, after reflection, they meet at focus na. So now indirectly we can understand, indirectly or directly we can understand that they are meeting at focus, reflected light rays, they are converging at focus. The focal length was given, that is F is the focal length. Now here is the distance from the pole to the focus is called focal length, nana. So then small f is equal to 20 centimeters given. Then he asks to find out the radius of curvature. Very easy bit. Now radius of curvature, R is equal to, one formula is here, R is equal to 2f. F is given, indirectly he has given, not directly. F is given, F is equal to 20 centimeter. The radius of curvature R is equal to, formula is 2 into F means 2 into 20. Then R is equal to 2 into 20 means how much? 40 centimeter. This is the right option. So which is the right option in the given bit part means, that is B is the right option. Okay. Which of the following is used in the solar cooker? The options given is, 8th question is, which of the following, 8th question, which of the following, okay, is used in a solar cooker? Which of the following is used in solar cooker? First option given is concave lens. B option is convex lens. C option is concave mirror. D option is convex mirror. Which of the following is used in solar cooker? Okay, solar cooker works on the principle of reflection of light rays. Okay, so lens was given, it is totally wrong. In lens, there is no chance of reflection, only refraction of light rays occurs. In respect of the lens, whether it is a concave lens or convex lens. So these two are ruled out. And we have only two options remaining. And which of these two is correct, we need to think. Concave mirror or a convex mirror. So convex mirror never converges the light rays. Convex mirror will diverge the light rays. Okay, instead of concave mirror, if you use convex mirror in the solar cooker, the reflected light rays will diverge. And for example, I will draw even that one also. This is a convex mirror. Okay, this is a pole and you focus, here is center of curvature. Okay, if I incident the rays, light rays onto the reflecting surface of the convex mirror, how the reflected light rays will behave? They will diverge. They will move like this. And if I extend these divergent reflected rays backwards, they will meet at the focus but in the mirror. So can you able to keep any vessel to heat up within the mirror? It's highly impossible. We can't do that. So hence convex mirror is also ruled out and left over is only concave mirror. Right option is C because it is acting like converging mirror. Now if I use a concave mirror like this is a pole, this is a focus, this is center of curvature. This is incident ray and this is reflected ray and this is incident ray, this is a reflected ray. So the reflected light rays are going to converge at focus. Here we are going to keep the vessel. So in this particular 8th bit part, multiple choice, the right option is a concave mirror. Is it clear? I hope you understood. Which of the following always gives virtual image? Okay. The option, which of the following will give always what images? Virtual image. Will be formed by which of the following always? The first option is, first he has given is, option is convex mirror. Second option B is concave mirror. And option D is prism. Option C is prism. Option D is glass slab. Glass slab. Okay. Which of the following gives always virtual image? So by seeing this multiple choice, we can rule out prism. Prism never forms any kind of images of the object. It can able to disperse the light rays, means dispersion for dispersion phenomenon. Formation of rainbow. Okay, we can use the prism. Okay, artificial rainbow formation. Okay, next one is glass slab. It can able to refract the light rays. Okay, that is while performing the activities. And we are having only two options here left, which has to be think. These two are ruled out. And virtual images will be formed always. Virtual image is formed by which type of mirror? The question is displayed on the screen. Virtual image is always formed by which type of mirror, means right option is convex mirror. Convex mirror always forms virtual images. It never forms real images. Whereas concave mirror will form, in 5 cases, it will form real images. In only one case, it forms virtual image, that is an object is placed between P and F. Convex mirror always forms virtual images only. Remember that 2 cases are there. One is object is at infinity, virtual image is formed at focus, that is in the mirror. Okay, highly diminished point sized. And for one more option is, if an object is placed on the principal axis, image is formed between P and F, virtual diminished. Okay, formed between P and F, virtual erect and diminished. If you want, I will draw even the ray diagrams in those 2 cases, that is for convex mirror. Now the first diagram is convex mirror. This is a convex mirror and here it is a pole and focus and this is center of curvature. Object is at infinity means all the light rays which are coming from the object which are at infinity are parallel rays. They are parallel to principal axis. Incident ray, incident ray. After incident on reflecting surface, it is going to diverge. It is going to diverge. If I extend these divergent rays backwards, they meet at a focus. Understood? So here the image is formed in the mirror. It is a virtual image, highly virtual, erect, highly diminished or point size formed at a focus. Okay, nature of the image means this is reflected ray I1, I2, this is R1, R2, you can write very clearly. And next one more case, virtual image. When does this convex mirror forms virtual image? Only two cases is possible for a convex mirror. That is, if an object is placed on the principal axis. This is second case. Okay, this is a pole and here it is focus, here it is center of curvature. Now object is placed on the principal axis. Now the incident ray is parallel to first ray, divergent ray, incident ray, reflected ray. This is I1, this is R1 you consider. Second ray onto the pole and reflects back like this. And if I extend this ray back forth, and if I extend this one back forth, and here the image is formed inside the mirror. So this is a virtual image. Okay, in the mirror means virtual image. So convex mirror always forms, only two cases is possible. It always forms virtual images only, and images nature are erect. One case, erect, highly diminished or point sized, formed at focus, that is when the object is at infinity. And next case is, if the object is on principal axis, whatever may the position of the principal axis, whether you keep here or here or here or here, image will be formed between P and F within the mirror, virtual, erect, diminished, formed between P and F. Okay, so the right option for this one is what mirror means? Convex mirror. Is it clear? Okay, I hope you understood my explanation. I will explain the second chapter in the next part. The coming videos you'll be getting the solutions for the second, third, fourth, fifth, and even other chapters. If you want, let me know about it. And please, if you understand my explanation, please like, share, comment, and subscribe. Thank you.